Well, everyone, this is Mr. 13 Things or Silence to Good, depending on what channel I'm loading this up to. And we're picking up this discussion, and hopefully we'll get a little bit farther here with why the site name We4D Kids. And so we've talked about already the idea that kids are in a 3D coordinate system from the time they start the game, definitely from the time they start to crawl and walk. They understand the colors of X being red, Y being green, and Z being blue. We need to leap them to the fact that the world is in 3 coordinates and give them another visual framework so they don't get mixed up, or they can kind of throw this in with their gaming world more than with their math world until the math world of what we're doing in our math classrooms and our testing and all that other stuff catches up with reality. So what I'm going to try to do here is erase all this out by trying to use some of my tools here so I can move forward to the next one. I can't do that, so I'm going to click back, forth. I'm going to grab here, and I guess that'll let me grab. I'm going to try to erase this out. Edit, cut, and what I want to do is to make sure I keep this around and this colorized. So I'm just going to erase everything. I can always draw the 3D coordinates. I'm going to grab that. Try to keep a consistent color, if you would, with this picture here, because this picture is going to be key, and I don't really care what color one uses. Kids can choose their own. It's probably a good, reasonable thing not to use green or blue, because if you're trying to deal with coordinate systems, right, and you're coming upon the fact that red is X and green is Y and Z is blue, then you might not want to use them in here, where here they are denoting colors, but I'll kind of live with that, my mistake for now, and you'll have to do the same. And now I'm going to go ahead and grab this and edit, copy, and then edit, paste, and move it around here, put that there. One of the beautiful things about SmoothDraw, it's not the only program out there, but it's what Sal Khan uses. So, and it's free, and it's got some incredible value. And then I'll go back and remember till we start to really get that it's pretty accepted in the design world that I can't draft. It's pretty accepted that X is red, Y is green, and Z is blue, even though some of us, right, have been, and we're still keeping our kids in this world where they never really think that Z's a part of math. They're used to this, and then with blue, never it being mentioned until late in high school. All right, so let's put some color values to this, so we know that this value, the length of that right there, is the square root of 2. The length of the orange there, if you would, go here, is the square root of 3. And let's see, square root of 4, or not, square root of 5, we're not going to deal with later on. You'll see these have some value up at 54 degrees, and then we'll do the green thing. And we'll start talking about the square root of 6. But really, the square root of 6 is the square root of 2 times the square root of 3. But then you're looking at an area relationship. This is a length relationship. And so we can go ahead and pull that. And we'll go ahead for now and say that that's the square root of 6. All right. Now, these come up all the time when you're looking at the basic cosines and sines. Now, what are cosines and sines? You might not want to mention that to kids right away. You might just want to mention it that there are some points on a circle that you're going to use to rotate. So I'm going to go ahead and just show you basically what those points are. Another one of these pictures that kids start to carry around. I'll do it for just, if you would, for just 45 degrees and for 30 degrees. I'll leave the 15 degree off for now. So at 45 degrees, right, that point there, let's see if I can do this, is edit, cut, edit, paste. The square root of 2, in fact, over 2. And in fact, it's also, that's the x coordinate. It is also the y coordinate. Now, you don't want to use all these crazy funky tools when you're doing that, obviously. So that, they're used to this bit, so that you know what those things are. And for now, you can show them that. But again, what is the square root of 2? It's this length. So you're kind of trying to incur in them or embed in them that where these square roots come from is usually the side of a square of area 2. So that gives you the coordinates of the x and the y here. And then for those coordinates, the x is more than the y. And let's see if I can do it here. So the x is, edit, cut, edit. Sorry to talk through this like this, but this is the kind of stuff those of you that are really good at smartboards probably are doing all the time. Why you'd have a smartboard in your home, I don't know, because this probably is not going to be done in a classroom. It's going to be done with someone who realizes their kids are gaming a lot. And it turns out then the y component, that's the terrible thing, is 1/2. So you're going to see these values are grabbable by students pretty quickly because there's a number pattern that I'm not going to show here that gets you what the coordinates are at pi over 4, which is 45 degrees and 30 degrees. And this is basically the cosine and the sine of 45 degrees, the cosine and the sine. You might not want to mention that, or you might want to mention it. You might call it animation, you might side mention it, but what you're going to realize is these are the values that you're going to plug in to do a rotation. You're going to plug in cosine minus sine, sine, cosine consistently into your matrix. Cosine minus sine, sine, cosine. So if you want to teach that without cosines, first minus the second, second, first. This pattern will emerge in 3 different places with some small sign shifts and cause and allow the student to do the rotations that they're quite used to doing with their head in 3D gaming. The translations you'll see are even simpler. So what does that look like? Let's go ahead and rotate about 45 degrees, a single point. And so what we'll do is we'll put a point, if you would, mathematically, right there, okay, which is basically, we'll call that 1 in the x. And so our point looks like this: 1 in the x, 0 in the y, 0 in the z, and always that 1 scale factor, right, which is pretty much ignored. You're going to rotate it 45 degrees in a positive direction. Hopefully you'll spend a day on right and left hand coordinate systems and get students used to that. We work kids in right hand coordinate systems and left hand coordinate systems, and we never tell them. When we're spinning counterclockwise, we're probably in a right hand coordinate system. When we're spinning clockwise, we're probably in a left hand coordinate system. We do that when we teach them compasses in the woods in 4th grade. So we start, I would always have you start with multiplying by the number 1 in matrix speak. This is called the identity matrix. Oh, that's wrong. 0, 0, 1, 0. I'll go ahead and cut these. So what you're going to do is you're going to show them in some repetitive way that this matrix is the same as the number 1. Why? Because of the identity rule. You multiply 1 by anything, you get the same thing. When you do that here by multiplying this row by this column, 1 times 1 is 1, 0 times 0, 0 times 0, 0. So you end up with the same thing. Right? 1, 0, 0, 0. So if you transform this by not changing anything, and you could actually go ahead and put in, oh, what is this? The cosine of 0 is 1. The minus sine of 0 is 0. This will all work out, believe it or not. What you're going to do to start, but quickly follow up otherwise, is to realize that you're going to be dealing with just these 4 when you're doing what we do in terms of planar rotations in the XY plane. So to turn it 45 degrees, you're going to then go ahead and you can do this, right? You're going to go ahead and you want to turn it 45 degrees. So what do? You're going to instead learn how to run this, and you're going to multiply it by the cosine, which is the first value. I'll leave the square root of 2 over 2, and then the sine, which is the square root of 2 over 2, but with a minus sign in front of it. And then you're going to use the square root of 2 over 2, and then the cosine is the square root of 2 over 2. And when you multiply this out, you won't get this value here. You'll get a different set of values. And that set of values will turn out to be right here at a value of the square root of 2 over 2 in both the x and the y. This will take some time, and this may be too much visually for the students to make that leap. So this is why, instead of doing this, you start to use this as a tool to review something you've already taught students. Call it project-based learning, call it Xbox, call it what you want. If the square root of 2 is 99 over 70, then the square root of 2 over 2 is 99 over 140. Same thing here, 99 over 140. These numbers remain the same. This, of course, had a negative in front of it. This, again, is 99. You get the bit. So you can do it with fractions, and when you end up, you will be at a point where you can graph it. This is probably even better done first with 30 degrees, because then your values here are different. As you go through and multiply this out, you can get to the point where students are rotating a single point in the XY plane, working in groups, redundantly and in parallel processing mode, if you would, that you have 2 sets of students doing the same calculations and checking them. But in the end, they can check their work with, in fact, a spreadsheet or a TI-83 calculator that many students begin to use. Best practice somewhere in the middle school, so I'm going to call it 5th grade. Now, not all the time, not at the risk of not learning their math facts, but all of a sudden, when you're multiplying 99 140th by something else, it seems like a good time to also break that into 3 times 3 times 11, prime factorization. And this one I won't be able to do. 2 times, I'm going to start with this, 2 times 10 times 7, which is 2 times 2 times 5 times 7. So you can very quickly start using all these things in a much richer environment than just the kind of crazy rote stuff that can then be checked with some pretty neat animation stuff that's very, very similar to what the kids have been doing since kindergarten. You start with 1 point, but once you do 1 point, you can do 2 points, which define a line. You can then do 3 points, which defines in sometimes an arc or a circle or something. You can then do more and more and more points, and very quickly students are seeing potentially the relationship between the math skills that they're going to learn and be tested on going forward and the computer skills that for now have not been put into an adopted standard. Even though the use of tablets and 3D and 4D and 5D, the 5th dimension being cost, we see the 5th dimension as cost or opportunity in the world around us. But here in the US, the accessibility of getting some sort of computing device into all of the kids' hands would be something that will occur in the next couple of years, no doubt. Thanks for listening.